Hey guys, today we're going to go over a couple of troubleshooting techniques with fiber connectivity. Here are a couple of techniques I use when I troubleshoot my connectivity. The first thing is to usually check the configuration on the interfaces to make sure they're already turned on. Next is usually checking the polarity of the laser to make sure that the transmit and receive are correctly plugged in its correct spots. Remember, when looking at the SFP, with the clip on the top, the left side is always to transmit and the right side is always to receive. So when looking at the fiber end, that means the left side is receiving and the laser is transmitting on the right side. Another thing to remember is that when working with single mode fiber, you're not going to be able to see the laser level at all. There are physical testers that can check for light levels. You can also check on light levels from the switch and router if the transceiver supports DOM, digital optical monitoring. So check on Cisco devices running iOS. In my example, I'm going to use gigabit 1/1. Show interface gigabit 1/1 transceiver. You're going to see two columns where it will say optical TX power and optical RX power. Those are the two columns that will tell us how much transmit, the TX, and the receive, the RX. Now for the Cisco iOS XE, the command is show controllers gigabit 1/1 PHY. There's going to be a little extra information there, but you're going to scroll down to midway after the hex digits. You're going to see the TX power and the RX power. When looking at the transmit and receive, the higher the number, the stronger the laser will be. Remember, just because you see a -20, it's not stronger than a -5. So the usual range that you want to see on the receive end is between -3 to -5. At this point, if you're still not getting connectivity, you probably have the wrong port connected on one end or a bad fiber. Sometimes even if a fiber cable is brand new out of a package, it can still be damaged, so always bring extra when working with them. Now we'll go over some scenarios in which you have established connectivity, but there may be some issues. When you have bad light levels, one or both ends of the devices tends to start producing CRC errors and or drop packets. Check light levels on both ends. Checking light levels using DOM on a device does not disrupt service. While of course using the physical tester, you will need to disconnect the fiber and reconnect the fiber to the tester. Once you find out which end is not at optimal receiving levels, double check with the side that is incrementing errors. Once confirmed with all the information, first you will want to make sure all the fiber cables are secured in the ports on the device and or patch panels. Next is to swap transceivers. After that would be changing fiber patch cables. If the connection has fiber patch panels in between, you might want to use a different port on the fiber patch panel. If there are no available other ports on that patch panel, you'll want to use this cleaning tool to try to clean that port. The old school way of doing this was to actually blow air from a distance on the fiber to remove the dust and debris out of the fiber core. Shockingly, I actually did this on my own. I actually gained 1 to 2 dBm from -7 to -5 after this technique. There is also a possibility that the fiber patch panel could have gone bad completely. If the two ends are within reach, directly connect the two devices to make sure that it is working. In order to troubleshoot bad fiber patch panels, you will have to test each and every hop in between by eliminating them one at a time. Some devices may have multiple fiber patch panels in between to reach end to end. On another note, when running fiber, you want to use the least amount of fiber patch panels. Not only does it decrease the number of points of failure, each and every fiber patch panel used decreases the light levels. The last thing is, if you have carrier equipment between two remote sites, This could also be a carrier issue, and this is not something that you can troubleshoot on your own. There you have it, guys. From my experience, check for polarity, check for the light levels, change transceivers and the fiber patches, and then check the entire fiber path from end to end. I hope this was helpful, guys. Don't forget to click that thumbs up and subscribe for more videos. Thanks for watching. See you guys later.